Okay, let's try a couple of problems. This one says, find the area trapped or bounded by g of x equals x square roots of x plus 1 and f of x equals 2x plus 2x rather. And I'll show you what my functions look like in my calculator. Just gonna hit graph. And you notice I don't get the best view of it, so I'm gonna change my window. So I'm gonna squeeze in here on the x. I'll go from, I don't know, -2 to about 5. And then my y's, I'm gonna go from -2 to about 7. So -2 to 5 and -2 to about 7. Let's see what it looks like now. All right, so if we're trying to find the area that's trapped, right? So if we put chicken soup in it, it couldn't go anywhere, right? Like that. That's what I mean by trapped. Trapped by those two functions, then it clearly is this region right here, right? So we should be able to drop this pin down and say which one is on top, and clearly the red one is on top, and then the black one is on bottom. And I always do top minus bottom. I think Sal from Khan Academy does upper minus lower, but I always do top minus bottom. Now you can do these one at a time if you decide to do that. Then the red one is 2x dx minus the bottom, which is the black one, which is x square roots of x plus 1, that whole thing, dx. Now you have to find these points of intersection from here to here. It's where your region runs. So we're just going to do second calc number 5, second calc number 5. Oops. Let me graph second calc number 5. So this will give us one of them. Okay, it says the point of intersection is out here at x equals 3. Again, kind of coincidence. X equals 3. And now we need to find this other point of intersection. Second calc number 5. We want to scroll over. You can't do them both at the same time. Please keep that in mind. So enter, enter, enter. Tells me the other point of intersection is right here at x equals 0. So both of these go from 0 to 3. 0 to 3. And since they have the same interval, they go from 0 to 3, then I should be able to smash them together. Now, if you do these one at a time, you get the exact same answer as if you were to smash them together, right? So the integral from 0 to 3 of 2x minus x square roots of x plus 1, the whole thing dx. Notice height times the base. Add up height times the base. That's what we're doing. Okay. So I'm going to put them together because I'm trying to save some time. So parentheses 2x parentheses minus parentheses x square roots of x plus 1. Let me close that off. Smash them together and I'll graph that. Please keep in mind that you get a hybrid, which is why our function is looking as it is. Okay, so we're going to do second calc number 7 from 0 to 3, and there you go. 1.26 units of area is the same thing as this. This too is 1.26 units of area. So 1.26 is coming from that, right? Okay, let's try another one. And let's take a look at this. It says find the area trapped between these two curves, but notice it gives us a starting x and an ending x now. So this is different than what we've done thus far. Okay, so let's sketch this out. So on the one hand we have x squared minus 4, and we also have, show that on my calculator, x squared minus 4, and we also have x plus 2. Now let's graph. Okay, so I'm going to sketch those out on my, let me change my window back to the -10 to 10. Give me a different view of it. Okay, so let me quickly sketch this on my sheet of paper. There you go. And then I'm going to put this in another color so that you can see it. Like that. Where this one is f of x equals x plus 2. And this other, this one, is g of x equals x squared minus 4. Now I have to be careful because it says not only do we want the region that's trapped between these two, right? If they said just trapped between the two, then there would be this region here, right? But what they're saying is you have to start at x equals -1, you have to end at x equals 2. So I'm going to go over here and figure out where those are. So second calc number 1, I'd like to evaluate my function at x equals -1. And notice it is right here. Right, so there's x equals -1. Okay, let's figure out also where x equals 2 is. So let's do second calc. Again, number 1. Find out what happens at 2. Okay, and you notice 2 is right here. So let me do my pinches. It has to be pinched between the function, the two functions, not the function and the x-axis. You got to pinch the two functions together. So it could be there, but it also has to be trapped between 1 and x equals 2. -1 and x equals 2, which means it has to be trapped between here as well. Okay, so this is the region that we're describing according to those pinches. Notice, yes, you're trapped between your two curves, bam, but also you're trapped between x equals -1 and x equals 2. So we're going to go about this in much the same way that we did the other one. We're still going to do top minus the bottom, right? So if I drop my ink pen, I can see that the red one is on top, right? What is that? X plus 2. So the integral of x plus 2 minus the bottom is this other curve, right? You can see it, it's the lowest one. X squared minus 4, the whole thing dx. Notice height times base. You have to have the dx down, otherwise it's wrong. Where does this start? Starts at x equals -1. And where's it end? Ends at x equals 2. Okay, so you can go on your calculator and do it all at once by smashing them together. Right? You can do them one at a time if you so desires, just more time consuming. Parentheses, x plus 2, parentheses, minus parentheses, x squared minus 4. Okay, by the way, this is directly in your notes. So please, 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 please use that as a resource. Second calc number 7. Lower limit was -1. Upper limit is 2. Okay, and there you go. 16.5 units of area. Notice again, this region doesn't look like that region, but they are one and the same. I smash these together, so I end up with a hybrid. By the way, when you find the area between two curves, it'll always be positive because it is an area, okay? 16.5 units of area.